Today, I'd like to talk about the encrypted client hello. It's an RFC that been proposed, I think, maybe 2 or 3 years ago by Cloudflare, so that the sensitive information that is exchanged in the beginning of the TLS handshake is completely encrypted now. But the question is how, and how much is this really the final piece of the puzzle for privacy, and how much configuration do you really need to do to enable this thing? So I'm going to talk about all that in this video. Stay tuned. So this article comes from Cloudflare. I'm going to have a link in the description. I'm not going to read the article. It's 5-minute read. You can go ahead and do it. But I'll go specifically on the diagrams aspect of it to explain encrypted client hello, and then give my take on certain things of what does it do to privacy and censorship in particular, because you see some countries prevent you from going to certain website, not only see where you're going, but actually block you from going certain places because they are the ISP. Right? And they control that. So all the IP packets going to certain location can be deep inspected, and given that the client hello as it is today has a property called SNI. I'm going to talk about it. Server name indication. I made many videos about it in this channel. But this property is a plain text of the domain that you're trying to visit. Now the question might be, Hussein, why do we need to add that if I am already knowing the IP address that I'm going to? I'm going to Google, I do a DNS, I get the IP address. That's it. I'm already connected to Google. What is this about another text domain that I have to provide? Well, you see, the basic assumption that I also had maybe 10 or 15 years ago was one IP address is equal one domain. And that is absolutely wrong, right? No, not the case. Maybe in the early or mid 90s, late 90s, maybe that was the case. But today, it's impossible. If you have an IP address, there might be thousands of websites on that single IP address. So how do you do that? You keep the connection, but then you send another indicator that tells you, hey, that's the actual service I want to go to. And the server will know. It's like, think of it in programming as like oversimplifying it, I know, but it's like a switch statement. Like, oh, if you're going to this domain, return this index.html. If you're going to this domain, right, return this this index.html. If you do this, then return this. Go to the database and query and return some payload. So it's literally as simple as this. Of course, I'm oversimplifying it, but using that indicator that tells you which website to, and also tells you which certificate to serve, so that you can trust that nobody tampered with the parameters and stuff like that. So that's what we're trying to hide, this indicator, which is called the SNI, which is always almost sent in every communication. So that's what happened in the TLS. We send the client hello first. White here is basically unencrypted. Blue is encrypted with the temporary handshake traffic key, and orange is actually encrypted with the symmetric key. And I talked about TLS. You can reference the video to learn more about it. So we send the client hello. We send the extensions, which is a key share, right? The parameters, and also there's something that's not here, but like pre-key share, like if you want to do 0 RTT, right? Our session resumptions. SNI, which is what we talked about here, the server name indication. Here's a plain text string that tells you, hey, I want to go to this service. Although we have a connection between this, I'm not talking about Quick here, just TCP. But although it's almost identical, right? The only difference is like UDP versus like an actual TCP stateful connection. Okay, so now we have SNI. We're sending that, right? And that is the problem. So between the client servers, there was tens of routers in between, right? Because these IP packets will have like, look, you can think of it like an IP packet, and there is like a destination IP address going that. So your IP address is visible. Forget about that, right? So everybody with this, that's not going to protect the IP address. For that, you need a VPN. to actually hide where you're going. Now, the VPN will know where you're going, but at least your intermediary won't know, right? So that IP address is like, no, right? So it's still visible. But the content here will have a plain text that says, hey, SNI, ALPN, like HTTP 1.1, HTTP 2. That's what I support as a client. And the server will receive that. But before the server receives that, it goes to your ISP, right? First it goes to your home router. Your home router says, all right, let me do the NAT, change the source IP address to a public one so that can't go really using a private IP address outside, right? And then the ISP receives it, and the ISP is free to deep inspect it, right? It's gonna deep inspect this, and then, all right, it's not encrypted, so I'm gonna look. Wink, wink, SNI, oh, you're going to this website. Nice. Let me log that this IP address went to this website on this day. And that's what we're trying to protect. We, like Cloudflare, trying to protect privacy. And because whoever in the middle can actually know that your IP address associated with this domain. So I'm going to visit this website. It does not mean they are looking at the exact text you're searching or what you're doing. They don't know any of that. It's all encrypted because it's all here in the orange side, right? They don't know anything about that, but they know the domains and they can block it. Some countries actually block it using this information. If you're going to an SNI, it's like, all right, sorry, you cannot go to this website because I'm going to look up the SNI and they literally either destroy the connection by returning a reset to you or just return some garbage, right? And then the connection will break. What happens today is the server will return the key share, which is public information, right? And it's unencrypted and some non-sensitive extensions here. It's like, okay, let's return that stuff, right? As part of this, the server hello will immediately prepare that the key share, the few cryptographic operation, and then send it. Just don't wait for yourself to prepare the certificate because the certificate needs a little bit more work, right? So that's how part of the optimizations that we think about as like backend engineers. Like think about this. It's like, oh, don't build all that stuff and then send it. No, send it as soon as possible. Shoot it, right? So using the SNI, we'll now look up the name here and we can play these games. Okay, so you're going to this website. Okay, this is the certificate for this website. And if you built anything with HA proxy or Nginx, there will be an exact parameters called SNI. If SNI this, return this public key, like PEM file, right? You don't really return the PEM file. You return just the certificate. Like the PEM has the private key. You don't do that. Well, you return only the part that is public, right? And that's the certificate. And the certificate verification, which has like signatures that make sure that nobody played with this. And then boom, you return it. And then also the private key that comes with the certificate, we use it to sign. So there's so much stuff here to protect the authenticity of the message. Boom, write it. And then we finish. And of course, the communication start communicating with the orange key, which is this symmetric key, right? And that's faster, of course, because it's symmetric. But the problem is this, the SNI. So what do we do, right? Here's how they do it with the encrypted client hello. So for the encrypted client hello, they introduce two client hellos, the outer and the inner. And the reason they did this, I suppose, is for backward compatibility, so that you still can, servers that don't support ECH can still just won't freak out when they receive this, right? It looks like a completely normal client hello, right? Because it's like it's an unencrypted client hello with an outer SNI, right? I don't know, part of me feels like this is overcomplicated. Like, I don't know. It's just, to me, that this is like there is outer and inner. I'm going to reserve my opinions on this one, but I don't know. It just feels like so overcomplication. Okay? For the goal that is the privacy on the domains. And I mean, what domains do you visit? Like X, Twitter, Amazon, Google. Like these are like, what else? It's like there's nothing. And most of people, content creators, are on these platforms. So what are you hiding? There's like to me, I don't care if if my ISP knows that I'm going to Twitter or Amazon. Right? Unless you're going to other websites specifically and you don't want people to know that you're going to. I know there are other websites, but I don't know. It seems like it's an overkill for all this stuff. But let's continue. And regardless. So you put your final destination in the inner hello, and you put the stuff that you don't care about in the outer. So I might say, what is the outer? Where do I come up with a fake ass website now, right? But yeah, that's the thing. That's the part of the complexity to me, right? So here, Cloudflare made up their own outer SNI. It's called literally Cloudflare-ACH, right? And that's their outer, right? So if you see that, what will happen is if there is an ISP, all of the IP will see, if they do a deep level inspection, they will see that, oh, you're doing a bunch of TLS to this ACH thing, and they won't see domains anymore, right? But the question that we didn't answer is like, encrypted with what? You're saying that this client inner hello is encrypted, but how? We never talked before between the client and server. So how would we actually encrypt this inner thing, right? That I really want to go to. Well, this comes with another technology that you must use for this to be effective, as called DNS over HTTPS, or DO, or ODO, the oblivious DNS over HTTPS. And that there is a record in the DNS when you say, hey, I want to go, because remember, this is all pointless if you're using unencrypted DNS, right? The whole thing is just pointless, because if you do a DNS and say, I want to go to, HusseinNasser.com, and you don't want to find other people go there, for example, right? If you go, you have to do a DNS, right? You do a DNS and say, okay, here's the IP address. That DNS by default, if you're using UDP on port 53, that's unencrypted, right? So your ISP already knows where you're going. So that's just, it's the whole thing out there, it's just pointless. You don't do any of that. You have to encrypt the DNS for this to become useful, right? So how do you do that? You encrypt the DNS by using this protocol that's called DNS over HTTPS. So you would connect using another TLS handshake to that server using normal TLS, and then you encrypt the communication with you, client, the DOH client, and the DOH server, and you encrypt the communication, and you send the UDP, the request for domains in that encrypted communication. So your ISP will only see that you're going to this 1111 thing on port 443, which is the HTTPS port, and then they don't even know that you're actually doing UDP. Or DNS. You're just doing web traffic. So, okay, feel free to go to 1111. I don't know what you're doing there, but sure. So you're sending in that. So Cloudflare knows that you went to HusseinNasser.com, right? So you asked for that. Right? And of course, another thing is like Cloudflare does not own HusseinNasser.com. They have to talk to Enum, which is my DNS authoritative server, and that communication is not encrypted. So the backend is all unencrypted. So don't think that this is all done and done deal. There is so much holes to plug here, right? And it's still, but it's like you might say, all right, if you're sniffing on the backend between Cloudflare and the DNS backend server, so it's all right. You don't know who made these requests, because the source IP address will be the DNS recursor for Cloudflare. It's not going to be you. They don't know that you made that. So someone wants to go to HusseinNasser.com. Big deal, right? It's not the end of the world, right? All right. So you made this connection. So Cloudflare technically knows where you're going, right? And you know that you source your source IP is connected to Cloudflare, so they know you want to go there. So Cloudflare made this whole thing that's called the Oblivious DNS just to hide the fact that, hey, you can use us just as a proxy, right? And we would never know any of that stuff, right? Just use this and this and this. And I don't even remember how it's done, right? But it's like, okay, if you use this, then... But that's not easy stuff, right? It's like all of this is just theory at this point, and I never seen an implementation of Odo, right? But yeah, so you figured out how to do a DNS. You asked and now your DNS queries are secure. Nobody knows them. Like, assuming, don't count Cloudflare. Cloudflare is that owns the whole internet at this point. They know everything. It's like, let's be honest, like, they are giant. They are everywhere. Everybody hosts with Cloudflare, right? So at this point, you make that DOH query, and you ask for an interesting thing. So you ask for your A records, you ask for A records or IPv6, IPv4, and a bunch of other stuff. But you also ask for something else called HTTPS record. I think it used to call the SVCB record. And that record has the public key of the domain that you asked for it. It has like a special rotated key. It's a public key, that's fine. This can be shared, right? And that public key, when you get it through the DNS, you use it to encrypt this guy. So you're using asymmetrical encryption with this. That's the dark blue, right? So you're encrypting this inner thing with a public key that you got using a DOH query on the HTTPS record. I'm impressed that they found a solution to this. It's really hard to think about all of this stuff, right? It's like, my God, is this really feasible to be implemented? Like, people will say, like, all right, take my money, just do it for me. What button should I click to enable all this crap? That's what you're going to do eventually. Nobody's going to implement their own, I don't know, ECH server, right? We can barely do TLS, right? Now we're gonna add an ECH server, so that's just part of the complication. I think that's the disadvantage that I see, right? But don't get me wrong, I'm not criticizing anybody working on this, right? I'm in love with this, but I have like kind of conflict. This is like, is there like an easy way? That's what I'm thinking, right? Anyway, so you do the client, you encrypt it with this public key, and then you do the outer thing, and that's the outer thing, right? So the outer thing, you need a client-facing server that actually understands ECH, encrypted client hello, right? Your server just not gonna work, right? You need a TLS library, and I've never seen any currently that supports ECH. Encrypted client hello, right? Let's actually do a quick Google search. Okay, so there is an open issue with 92 likes, and there's some activity here. So there is some activity, but it's not yet closed, so that means it's not supported, right? So that's OpenSSL. That's like the most popular one, right? Probably is this gonna be supported in the rest? So it's gonna be supported soon, but I don't know when exactly. Yeah, I don't see any pull requests that. So yeah, it's not like you can just host OpenSSL and just work with this and do all that stuff, or it might be supported in others. But yeah, it's complicated nevertheless, right? So just to have these inner query, because what happens is your server, let's say you have a backend server that supports ECH, right? Your server should first decrypt this like it's normal because it doesn't know it's an outer, right? So it decrypts, it just takes that unencrypted client hello and just takes the SNI, and you should know that, oh, this is particular SNI is just, I know that this guy wants, they support ECH, because that outer SNI is definitely an outer SNI, right? It knows from the name. I suppose that Cloudflare they do mention that's their outer SNI. It's called cloudflareech.com, right? So if you're on top of a Cloudflare, you're automatically going to use that. And I put like, the question is like, how do I know what's this outer SNI, right? Someone's gonna tell me. And does the HTTPS record tell you? I don't know, to be honest. It's not mentioned in this blog. That's interesting, right? I would suppose that HTTPS record will tell you that, oh, by the way, use the outer SNI for this, and use that's their outer SNI, right? And that's how you communicate with us. Probably, right? But yeah, you'll communicate there, and then the server will take that and says, all right, I can successfully, I know you're going there, but I'm gonna ignore this. I know you went to this outer SNI, but let me try to decrypt this inner thing, right? Using my private key, because you have the matching private key that is for the public key that you put on the HTTPS record, right? On your DNS DOH, right? I know there's so much moving parts here. And then you take that guy. If you can decrypt it, then you just finish the communication. You just send the certificate verify encrypted. So that's good. So even the certificate is encrypted. So because if the certificate is not encrypted, that's also pointless, because someone sniffing in the middle is there, you just sent the certificate as a plain text. I just knew where did you go. Right? So you can't really send the certificate as a plain text. It has to be encrypted. So the cert is also encrypted. It's not compressed yet, so that's bloated, especially if you include the root and the intermediary. So it's big bloat, right? That's another thing I talked about. So just boom, you send that, right? But you send also the server hello. And then you communicate, and you're done. Right? But what if I can't decrypt this thing? What if I cannot decrypt it? Right? If you can't decrypt it, you then finish with this outer thing, right? And then the client, when they see you actually sending the certificate for the outer SNI, then they must close that connection, because they know that, oh my God, you're not it. Either you are not it, or you are it, but you are telling me that the public key I use is probably outdated. So here is where the server actually respond back with, hey, by the way, you got it wrong. Wink, wink. Here's the new public key. Go and do that, right? Do that using that. So you will close the connection and reconnect again, and then send another client outer with the client inner and do that. So that will bloat the client hello. Yeah, think about it. All the client hellos are now way bigger. Right? How bigger? I mean, like you have the key share inner, so it's not really that big, but it's double in size at least. Right? There's an increase in the client hello. Right? So that will slow down TLS clients with a small initial window in the congestion control if you're on top of TCP, because you start always slow, right? I mean, you start with the minimum now is like 10 maximum segment size, so you can't send a lot, but is it enough for both of these? So that's actually a concern. If everything, especially like if you started sending that and then turning around and reconnecting, that could be like another hit for you. Right? So let's talk about a little bit about the privacy. So we kind of agree that, yeah, sure, okay, it's private, but Cloudflare knows, right, But no, they don't know. You can use the ODH, DOH, use the oblivious thing. But I'm still connecting to you guys here, the ACH thing. Oh yeah, because you're a customer with us in the Cloudflare. So how do I do that for my own, completely on my own? Yeah, you have to spin up your own ECH server, and you have to have your own outer client thing, right? You have to do all of this yourself, right? And I really doubt that normal people will do that, right? Big cloud provider might follow, right? I don't hear anything from Google servers per se, but Chrome did support the client side aspect. Did I mention that? I probably didn't. Yeah. I'm using Safari, that's why it says you're not supported here. But Chrome actually supports this thing now. Yeah, you can enable it. I actually enabled it and it works. Well, how do I know it works? I would visit this website as a test, right? I didn't look at the Wireshark. I'm getting an error when I fire up my Wireshark, so I didn't look. But if you look through Wireshark, you should see all this stuff, outer client, inner. You wouldn't see it inner because it's encrypted, and there's no way for Wireshark to actually decrypt that. But yeah, you'll see that, HTTPS. Sorry, they talk about this. That's actually a very nice summary. I love it. Yeah? They managed to summarize all of that in just a very nice paragraph. I love it. So 117 has this. But let's talk about what does it really do for like censorship, like countries that do censorship, right? It doesn't do anything, right? Because, well, the pinner on this is DOH, right? Because they're trying to solve privacy. There's a big difference between privacy and censorship, right? Privacy, okay, in the US, of course, you can't just block things, right? Like to be private will do all of that. But simple thing, if I want to censor this, the moment you start using DOH, you cannot use DOH, I'm sorry. But how would you know that I'm using DOH? Well, there are very few servers that actually support DOH, right? And this is this IP address. The moment you connect, because DOH is interesting, because DOH, there is no DNS for it, as far as I remember. You cannot DNS yourself for a DOH server. You have to use the IP address, right? And if you use the IP address immediately, that's a flag that tells the ISP that, oh, that's definitely a DOH server, right? That's one way to find out. And if you're a DOH, just like block it. And if you're blocked, you cannot use any of the internet if you're using DOH, right? And I'm assuming I'm a country with a regime that I want to censor your stuff, right? As a citizen, right? So to do that, hey, the moment you use DOH, I just block you. I'm sorry. You're just not allowed to use DOH. And the moment you don't use DOH, this whole thing is just pointless anyway, right? So you'll fall back to normal stuff and you'll send us SNI like a good boy, right? And if you send us your SNI, I know where you're going, and just let us just log your stuff and be your merry way, right? Fortunately, this is not a solution, to me at least. I can't think of a way for censorship here, because it all is built on top of DOH, and DOH is clearly known that to be a server, unless they find a way to make a DOH server that doesn't look like a DOH server, right? Like, let's say I spin up, like if there's an easy way to spin up my own DOH server on a public IP address that is, like, say, AWS, which the country cannot block, right? Easily. Then I can spin up my own DOH server. I can connect to that, right? And then, yeah, my DNS now is encrypted. Now I have to point all my clients to use this DOH server. I have no idea if this is even configurable or not, right? DOH is not really something built in the operating system. DNS is, but DOH is not. It's a new thing, right? So that's another thing. I know I was a little bit pessimistic, but I don't know. I'm just telling the truth, to be honest. I don't see this, getting implemented worldwide, especially in countries that they enforce censorship, right? if this is like, if a lot of people have like, oh, this is gonna be good for censorship or whatever, I don't think it will, because like you have to spin up your own DH server. If you even figure that out, then you have to figure out how to spin up, how to make your OS connect and use all of this stuff through DOH, right? Then you have to configure your DOH server with your website to have all that stuff, right? Then you can visit websites, assuming their back-end websites actually support ECH. That's a good point. Like, yes, if you're going to a website that is not on top of Cloudflare, right? Let's say a sensitive website that's like the country your country or a country want to block, right? If that website doesn't support ECH, the whole thing is just pointless, because you cannot. Because the back end must support ECH in order to do anything, right? If they're using, that's why the last statement of Cloudflare here says, over time, we hope others will follow our footsteps, leading to a more private internet for everyone. The more providers that provide ECH, the harder it becomes for anyone to listen in on what users are doing in the internet. Heck, we might even solve the privacy for God. So again, to talk about privacy, not censorship. It's a very big thing, right? Because a lot of people on Twitter, it seems like, oh, this is going to solve censorship. That's awesome. Unfortunately, I don't think so. Yeah, I don't think it's going to solve censorship. It's only going to solve privacy. And if everybody starts supporting this stuff, right? Again, technology is sound. I love it. I love talking about technology specifically here. The way they solve this is nice. I think it's, I don't know, it's just so many moving pieces, but I don't like to criticize something without having other options, because I can't think of another options, to be honest, because smart engineers put years of their work on this thing, right? And I'm not that smart, of course, to know all of that stuff. There is so much here, and you kind of have to play nice with existing tech to actually do all that stuff, right? Yeah, I don't know. What do you guys think about this? Yeah, gonna see you in the next one.